Hello everyone, I am Balaji Rao. Welcome to BR Max class. This is 5th class in Ncert chapter. Till now we completed 4 exercises in Ncert chapter. This 5th exercise is easy, but you need to have good grip on complement of a set definition. So in the first 10 minutes I clearly explained what is complement of a set and what are the properties of complement of a set. Even though if you understand the definition of complement of a set, in third problem you may confuse little bit. I just want you to listen carefully when third question is going on. In case if you felt any difficulty in that, you just come back and you try to understand. As these videos are recorded videos, you can go back and you can check what is the explanation for that. Still, in case if you felt difficulty, you please comment below so that in live classes I'll discuss this problem again. Without much delay, let's begin the class. Complement of a set. What is the definition of complement of a set? Complement of a set A is denoted by A dash or A power C, A bar. Generally, complement of set A is denoted by A dash. And how it is defined as all the elements present in universal set U but not in A. All the elements present in universal set but not in A. Try to understand. A dash is all the elements present in universal set but not in A. We will try to understand what is A dash by using Venn diagram. You observe this Venn diagram. This is set A. Which zone is known as A dash? You observe this lines part is there na, like this lines part is there na. This part is nothing but A dash. You try to understand all the elements present in universal set but not in A. So A dash is all the elements present in universal set but not in A. So A dash is U minus A. Now we'll try to understand few important points related to complement of a set. You see this A dash means not A. A dash whole dash. A dash whole dash is nothing but A. It can be understood easily. A dash whole dash equal to A. Complement of universal set. Complement of universal set is defined as empty set. Complement of empty set. Complement of empty set is defined as universal set. Now see the 5th point. A union A dash. When we do A union A dash, what you will get? You observe here. This is set A and this part is A dash. When we do their union, what you are getting? You are getting universal set. You can understand this easily. This is set A. This circle is set A. And this horizontal, this lines part is there, na? That is A dash. If we do their union, we will get this total box. This total box is nothing but universal set. So A union A dash is universal set. A intersection A dash. You observe that A and A dash both are disjoint. There is no element common in A and A dash. So A intersection A dash is null set. Now De Morgan's law. A union B whole complement. A union B whole complement is A complement intersection B complement. Similarly, A intersection B whole complement can be written as A complement union B complement. These are known as De Morgan's law. I'll try to prove this De Morgan's law by using Venn diagram. You observe here, this rectangular box is the universal set and this is set A and this is set B. If you observe this Venn diagram, in this total 4 parts are there. You observe only A is part 1, intersection of A and B is part 2, only B is part 3. Other than these circles, whatever the remaining place is there, that is 4th part. Please try to understand what is 4th part. Other than these circles, this whole thing is 4th part. Now you see, I will try to prove this first result. A union B whole dash. What is meant by A union B whole dash? Here you try to understand A dash means not A. So A union B whole dash means which part you will get. You try to understand. A union B whole dash. A union B whole dash means not A union B. Not A union B means which part will come? Which part will come, you please tell. Fourth part is not A union B. Okay. Now A dash. A dash. What is A dash? A dash means not A. Other than A, what parts are present in this? 3 and 4. So what is A dash? A dash is 3 and 4. B dash. What is B dash? B dash. B dash means not B. Not B. That means 1, 4. You try to understand this. 1, 4. Here, what is A dash intersection B dash? A dash intersection B dash is the common part present in A dash and B dash. What is the common part present in A dash as well as B dash? That is fourth part. So you can easily understand here A union B whole dash is nothing but A dash intersection B dash. Similarly, we can observe that A intersection B whole dash is nothing but A dash union B dash. And last point, what is A dash? A dash is nothing but not A. In general words, you can remember it. A dash is nothing but not A. This is exercise number 1.5. In this exercise number 1.5, most of the problems based on complement of a set. Before starting this exercise, it is important that you must good in the definition of a complement of a set and you know how to calculate complement of a set. Let's see the solution of first question. Okay. The question is like this. They given universal set, set A, set B, set C. They are asking us to calculate A dash, B dash, like this bits are given. What is the formula to calculate A dash? The formula for A dash is U minus A, universal set minus A. B dash formula is U minus B. So first what I'll do, I'll write universal set. See, this is the universal set, right? Minus, I'll write set A. How to write U minus A? Very simple. In difference of sets, we learn in the same way. U minus A means first you identify the common elements in both. 1 is common in both, 2 is common in both, 3 is common in both, 4 is also common in both. Other than common elements, what elements present in first set? That is the answer. Other than common elements, what elements present in first set? Here, other than common elements, what elements present? 5, 6, 7, 8, 9. I hope you understand. What is this? This is A dash. We calculated A dash. Similarly, in second bit, what they are asking? They are asking B dash. What is the formula for B dash? The formula for B dash is U minus B. First, I written universal set minus set B. How to write U minus B? You just identify the common elements. 2 is common in both, 4 is common in both, 6 is common in both, 8 is common in both. Other than common elements, what elements are remaining in first set? That is U minus B. So what are remaining? 1, 3, 5, 7, 9. So that is B dash, right? Now they are asking to write A union C whole dash. B dash formula is U minus B. C dash formula is U minus C. In the same way, A union C whole dash formula is what? U minus A union C. Okay. So before calculating U minus A union C, I need to calculate A union C first. So I'll calculate A union C. A union C, we learned in third exercise how to calculate union of sets. Okay, very simple. First you write set A. What is set A? 1, 2, 3, 4. Now you write set B also. But before that you check that any already listed elements are there or not. For example, before writing 3 already listed here. So no need to write it again. So write 4. Before writing 4 is listed here or not? Yes, it is listed. So no need to write. Next 5 is not listed, 6 is not listed. So here you take any element in A union C. If you take any element from A union C, it means that that element is present in A or present in C or present in both. So A union C whole dash is what? A union C whole dash is U minus A union C. Universal set given in the question only. 1, 2, 3, 4, 5, 6, 7, 8, 9. Just now we calculated A union C, 1, 2, 3, 4, 5, 6, right? So difference of these two sets. Writing difference of two sets is very easy. First, you identify the common elements. 1 is common in both, 2 is common in both, 3 is common in both, 4 is common in both, 5 is common in both, 6 is common in both. Other than common elements, what elements are remaining in first set? That is the answer. What is the answer? 7, 8, 9. Okay, now come to this A union B whole dash. A union B whole dash means universal set minus A union B. Okay, before calculating this, first I'll calculate A union B. So that's why I written set A union set B. Okay, that equal to, now how to write A union B? First you write 1, 2, 3, 4. Now you write 2. Before writing 2, you check here it is already listed. Now you write 4. Before that you check it is already listed. No need to list it again. 6, 8. So A union B is 1, 2, 3, 4, 6, 8. Actually what we need to calculate? We need to calculate A union B whole dash. A union B whole dash is universal set minus A union B. So first I written here universal set minus A union B. What we got? A union B is just now calculated now. 1, 2, 3, 4, 6, 8. 1, 2, 3, 4, 6, 8. Now difference of these two sets. You just identify the common elements. What are the common elements? 1 is common in both, 2 is common in both, 3 is common in both, 4 is common in both, 6 is common in both, 8 is common in both. Okay, that equal to what you will get here? 5, 7, 9. A union B whole complement is 5, 7, 9. Okay, now you see the fifth bit, A dash whole dash. What is A dash whole dash? Actually we have a formula for A dash whole dash. Best method is use that formula. A dash whole dash is A. What is set A? In the question you observe, what is set A? Set A is given as 1, 2, 3, 4. So A dash whole dash is A. That is nothing but 1, 2, 3, 4. You can write like this. Okay, now B minus C whole dash. B minus C whole dash means universal set minus B minus C. Just observe, A dash is U minus A, B dash is U minus B, like that. B minus C whole dash is U minus B minus C. To calculate this, first I need to calculate B minus C. Okay, what is set B? In the question, set B is given as 2, 4, 6, 8. Okay, minus set C. In the question, set C is given as 3, 4, 5, 6. Okay, B minus C. You identify the elements which are common in both. 4 is common in both, 6 is common in both. Other than common elements, what elements are remaining in first set? That is the answer. So B minus C is what? B minus C is 2, 8. Now B minus C whole dash. What is the formula? U minus B minus C. Now universal set. What is the universal set? Universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9 minus B minus C. What is B minus C? B minus C is 2, 8, right? You write 2, 8. Now you identify the elements which are common in both. 2 is common in both, 8 is common in both, right? So what you will write here, this is equal to, other than common elements, what elements are present in that set, first set? That is the answer. So what you will get here, the answer is 1, 3, 4, 5, 6, 7, 9, right? So this is B minus C whole dash. I hope you understand the solution of first bit. Actually it is very easy. Now let's move to second question. You observe here what they given. Universal set is given. Find the complements of the following sets, right? This is similar to last problem, so I'll try to explain quickly this. They given set A, they are asking to write its complement. Okay, A dash. What is A dash formula? U minus A. A dash formula is U minus A. First I written the universal set, right? Minus set A. What is set A? Set A is ABC. This is difference of set. Now how to calculate? First identify the common elements. A, B, C are common in both. Other than common elements, what elements are remaining in first set? That is the answer. What elements are common in first set? D, E, F, G, H. So A dash is D, E, F, G, H. So A complement is D, E, F, G, H. I hope you understand. Similarly, b dash. What is the formula for b dash? The formula for b dash is u minus b. The formula for c dash is u minus c. Very simple, right? So b dash u minus b. I written universal set and then I written set b. U minus b, difference of sets. Very simple. First identify the common elements. D, E, F, G. These elements are common in both. Other than common elements, what elements are remaining in first set? That is the answer. A, B, C, H. This is b dash. Now a third bit, they given it as a set C. Okay, I need to write its complement. C dash. C dash means u minus c. C dash means u minus c. So first I'll write the universal set, right? Universal set minus c. Now you identify the common elements. A, C, E, G are the common elements in both the sets. Other than common elements, what elements are remaining in first set? That is the answer. B, D, F, H. I hope you got this point, right? Now D dash. What is set D? They given in the question. In the question, set D is given as F, G, H, A. Okay, D dash means u minus d. First I written universal set and the set D given in the question like this, F, G, H, A. That is what I written. Identify the common elements. Other than common elements, what elements are remaining in first set? That is the answer. B, C, D, E. I hope you understand the second bit. This is very easy. You observe this third question. Many students feel difficult to understand this. Actually, if you know the definition of a complement of set, if you have grip on what they are exactly trying to say in complement of a set, this is easy only. You observe this question. Taking set of natural numbers as universal set. Here they are taking what is universal set? Set of all natural numbers. You look here, I written. What is universal set? Set of all natural numbers. I written natural numbers here 1, 2, 3, 4, 5, 6 like that. Write down the complements of the following sets. Okay, they given first set like this. X says that X is a even natural number. Look here, X says that X is a even natural number. To write its complement, I named this set as set A. Okay, I written this set as, named it as A. Okay, this set is in set builder form, right? Given set is in set builder form. I just want to make this easier, so I'll write this in roster form. Roster form means all the elements are listed and separated by commas within the brackets. X is even natural number. Na? What are even natural numbers? 2, 4, 6, 8, 10 and so on. These are all what? These are all even natural numbers. Actually what they are asking to calculate, write down the complements of the following sets. Complement means A dash. What is A dash? A dash formula is universal set minus A. Okay, what is universal set? Set of all natural numbers is the universal set. Na? So you write universal set 1, 2, 3, 4, 5, 6 and so on minus set A. What is set A? Just now we got here. What is set A? 2, 4, 6, 8, 10. Set of all even natural numbers. Now you look here, we got difference of sets. How to calculate difference of sets? First you identify the common elements. 2 is common in both. 4 is common in both. 6 is common in both. Actually here 8 is also present. 10 is also present in this set. Now you observe other than common elements, what elements remaining in the first set? 1, 3, 5, 7. These elements are remaining in first set. That means these are all odd numbers. Please try to understand. These are all odd numbers. See here, X is even natural number. What is its complement? Its complement is U minus A. That means all the elements present in universal set but not in A. What are such elements which are present in universal set but not in A? A contains even numbers. A dash contains odd natural numbers. Very simple. So if I write this answer, what I'll get? Set of all odd natural numbers 1, 3, 5, 7, 9, 11 like this. Set of all odd natural numbers. Other than even numbers, what elements are remaining in first set? That you need to write. So this is A dash. You can write this in another method also. Here A dash is there. You can write like this. X says that X is a natural number and X is odd, or else X is odd natural number. For A dash, you can write like this. X says that X is odd natural number. Like that also you can write. However, I felt that every student can understand if I do this problem in roster method. So I written given set in roster method so that you will get answer like this. I hope you understand this. You observe this set is in set builder form. To understand the things are easier, I just want to write set B in roster form. Odd natural numbers. What are odd natural numbers? 1, 3, 5, 7, 9, 11, like that. These are all odd natural numbers. This is set B. Actually, what I need to calculate? I need to calculate B dash. What is B dash? B dash is universal set minus B. What is universal set? Universal set is set of natural numbers. So 1, 2, 3, 4, 5, 6, 7, like that. Set of all natural numbers minus set B. What is set B? Set of all odd natural numbers. I can explain this in set builder form also, but I want you to understand this easily. So I am doing this problem in roster method. Now, difference of these two sets. Difference of these two sets means first you identify the common elements. 1 is common in both, 3 is common in both, 5 is common in both, 7 is common in both, 9 is also common in both, 11 is also common in both. So you identify what elements present in first set other than this second set, other than these elements, other than common elements. What elements are present in first set? You observe 2, 4, 6, 8, 10. Even numbers. Even numbers are present in first set. So here what I can write this as B dash as 2, 4, 6, 8, 10, like that. The same thing you can write, you can stop this problem here, but you can write like this also. B dash equal to X says that X is even natural number. Even natural number, right? That is complement of given set B. I hope you understand. In third bit, they given like this. X says that X is a positive multiple of 3. Okay. X says that X is a positive multiple of 3. I'll try to do this problem also in roster method. Positive multiple of 3. What are positive multiples of 3? 3, 6, 9, 12. Actually, they are asking us to write a 3 table. 15, 18, like that, right? I am writing these sets in roster form so that you can understand complement very easily. I can write its answer directly also in set builder form. What is C dash? C dash is universal set minus C. What is universal set? In the question they are saying that set of all natural numbers is the universal set. 7, 8, like this. These are all set of all natural numbers minus what is set C? Set C is 3, 6, multiple of 3, 12, 15, and so on, like this. Now you observe the elements which are common in both 3, 6, 9, 3, 6, 9, 12. That means here what elements are remaining first set? You observe they are not multiple of 3. Please observe that point. That means I can write here 1, 2, 4, 5, 7, 8, 10, like that. But you observe other than common elements, what elements are remaining in first set means they are not multiple of 3. So this answer I'll write here C dash. C dash equal to, you can observe answer will be like this. 1, 2, 4, 5, 7, 8, 10, 11, not 12, 13, like that you will get. Instead of writing like this, best idea is write this in set builder form. X says that X is a natural number, no doubt in that, and X is not a multiple of 3. X is not a multiple. X is not a multiple of 3. I hope you understand. You observe set D. Set D is given like this. X says that X is a prime number. Okay. You know what are prime numbers. You write this set in a roster form. 2, 3, 5, 7, 11, 13. Like that. It's an infinite set. Okay. This is set of all prime numbers. Actually, what they are asking to calculate? They are asking us to calculate complement of D, that means D dash. What is D dash formula? U minus D. What is universal set? Universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. Set of all natural numbers is the universal set. Minus, what is set D? Set D is there here. This is set D, set of all prime numbers. Okay, you see here universal set minus D. You identify the common elements. See here, 2 is common in both, 3 is common in both, 5 is common in both, 7 is common in both, right? 11 is common in both, 13 is also common in both. Here what are the elements remaining in first set? 1, 4, 6, 8, 9. You observe, other than 1, what about other elements? 4, 6, 8, 9, 10. These are all the composite numbers. Please try to understand. 4 is a composite number, 6 is a composite number, 8 is a composite number, 9 is a composite number. D dash is also known as not D. X is a prime number means X is not a prime number. Not a prime number means what? Which is not prime, which is called composite number. So here what I need to write here, actually I'll just write in roster form. You observe 1 is present, next 4, 6, 8, 9, next 10, 12, 14, something you will get like this. This is D dash, but it is better to write the answer in set builder form. D dash is X such that X is a natural number, or else I do one thing. X, okay, I'll write it. X is a natural number, comma, X equal to 1 and X is a composite number. X is a composite. X is a composite number. I hope you understand this. So if set D is given like this, its complement is like this. X says that X is a natural number, X equal to 1 and X is a composite number. This is the complement of given set. I hope you understand this fourth bit. Now from this fifth bit onwards, I'll try to write all answers directly in set builder form only. You observe here what is they given. They given X says that X is a natural number which is divisible by 3 and 5. I need to write its complement, right? First I named this set as D. Okay. D dash is what? D dash is universal set minus D. Okay. Here natural number, X is a natural number divisible by 3 and 5. D dash is also known as not D. Not D. That means X is a natural number and not divisible by 3 and 5. Simple way to answer. X is a natural number and not divisible by 3 and 5. See here, same thing I written. X is a natural number and X is not divisible by 3 and 5. Over. Simple thing it is. Right? Now come to E. This set complement we need to calculate. I named this set as E. I named this set as E. Okay. Now E dash formula is U minus E. Basic idea is what? E dash is also known as not E. Not E. Here E is what? X is a perfect square. What is E dash? Not a perfect square. Simple. Look here. X is not a perfect square. And we know that all the elements must be in universal set. What is universal set in this question? Set of all natural numbers. That's why I specified X must be natural number and X is not E. Not E means X is not a perfect square. I hope you understand this. You see next bit what they given here. They are in the question they are saying that X is a perfect cube. I named this set as F. I need to calculate its complement. That means F dash I need to calculate. F dash means U minus F. F dash is also known as not F. Okay. Here F is what? X is a perfect cube. F dash means what? Not a perfect cube. Very simple. As all the elements must present in universal set, in the beginning I will specify that X is a natural number and X is not a perfect cube. Very simple. A dash means not A. B dash means not B. Keep this point in your mind. Okay. Next set G is given like this. X says that X plus 5 equal to 8. I can do this problem in two methods. What is G dash? G dash means not G, correct? not G. Here x plus 5 equal to 8 is there. Directly I can write x plus 5 not equal to 8. Because G dash is nothing but U minus G na. U minus G. All the elements must present in universal set. That's why written x is a natural number and x plus 5 not equal to 8. This problem is over. Or else you can simplify this set. Here this is the set G na. X says that you take 5 to this side. 8 minus 5 is 3. X says that x equal to 3. Given set can be written like this. Given set can be written like this. What is its complement? X says that x is a natural number and x not equal to 3. For this problem, you can write answer in two ways. This is the one method. Okay, you can write like this and you can stop it. Or else, first you write set G like this and you write G dash like this. I hope you understand this. Now, come to this ninth bit. They given this one. I named this set as H. Okay, I need to write its complement H dash. Here, what is there? 2x plus 5 equal to 9. H dash means not H. That means 2x plus 5 not equal to 9. But the point is H dash means universal set minus H. Universal set is natural number here. Whatever will present in H dash, they must be natural number. That's why I specified here. X says that x is a natural number and 2x plus 5 not equal to 9. Okay. Now come to the 10th bit. X says that x greater than or equal to 7. Okay. I taken this set as I. Now I need to write its complement. Greater than or equal to 9. Complement means not greater than or equal to 7. Greater than or equal to complement means not greater than or equal to. Not greater than or equal to means strictly less than. Not, you cannot write less than or equal to because here equality is there now. Whenever they given greater than or equal to, while saying not, we'll say less than, strictly less than. Look here, x says that x is a natural number and this is greater than or equal to. Now I'll say that x is less than 7. Not greater than or equal to 7 means x is less than 7. You can write like this also. X says that x is a natural number and x is not greater than or equal to 7. That means x is less than 7 only. Okay. Now you see this ninth bit. They given like this. X says that x is a natural number and 2x plus 1 is greater than 10. Here its complement. Here greater than is given. Not greater than 10 means less than or equal to. Try to understand. When they given greater than, while writing its complement, you will write less than or equal to. When they given greater than or equal to, while writing its complement, you will write less than. Okay. This is the set J they given. I need to write its complement, right? X says that x is a natural number and 2x plus 1 is less than or equal to 10 because they given greater than 10. You see this fourth question. They given universal set, they given set A, they given set B. They are asking that verify this bit and this bit. First, let's see first one. Now, I need to verify this by using given sets. They are not asking proof. They are asking to verify this by using given sets. What I'll do, first I'll calculate LHS. Next, I'll calculate RHS. If LHS is same as RHS, then I can say that this first bit is verified. Okay, so I'll do the first bit. In this first bit, to calculate LHS, you observe here what is there. A union B whole dash is there. Formula is universal set minus A union B. A union B whole dash formula is universal set minus A union B. So first I'll calculate A union B. So I'll calculate A union B. A union B. What is set A? Set A is 2, 4, 6, 8. Union. What is set B? Set B is 2, 3, 5, 7. Now I need to calculate its union. Very simple. First you write full set A. 2, 4, 6, 8. I written set A. Okay. Now you write set B also. But make sure that no repeated elements. You write 2, but 2 is already listed. No need to write. Now you write 3. Okay. Next you write 5. Okay. 5. Next 7. So A union B is 2, 4, 6, 8, 3, 5, 7. Now actually I want to calculate A union B whole dash. Okay, A union B whole dash formula is what? The formula is universal set minus A union B, correct? Okay, what is universal set? After reading the question, we can easily say that universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see the question, universal set is given minus A union B. What is A union B? Look here, A union B we got like this 2, 4, 6, 8, 2, 4, 6, 8, 3, 5, 7. Okay, so here difference of sets is there. So you just identify the common elements. 2 is the element which is common in both. 3 is the element common in both. 4 is the element common in both. 6 is the element common in both. 8 is the element common in both. 7 is the element common in both. 5 is the element which is common in both. After identifying common elements, what elements are remaining in first set, that we will write, right? You already know this by this time. We did so many problems like this. So what you will get? 1, 9. So A union B whole dash is 1, 9. So here I'll take this as 1. Okay, I'll take this as 1. A union B whole dash. A union B complement is set 1, 9. Now I'll calculate this RHS. What is RHS? A dash intersection B dash. For that, first I need to calculate A dash. Okay, A dash. What is A dash? A dash is universal set minus A. What is universal set? In the question they given that universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9. Minus what is set A? Set A is 2, 4, 6, 8. Set A is given as 2, 4, 6, 8. Now this is difference of sets now. First you identify the common elements. 2, 4, 6, 8 are the common elements. Other than common elements, what elements are remaining in first set? That is the answer, right? So what you will get here, the answer is 1, 3, 5, 7, 9. So A dash is 1, 3, 5, 7, 9. To calculate RHS, now I'll calculate B dash. B dash means U minus B. Okay, so B dash. What is B dash? Universal set minus B. What is universal set? 1, 2, 3, 4, 5, 6, 7, 8, 9 minus what is set B? In the question, set B is given as 2, 3, 5, 7. Okay, 2, 3, 5, 7. Now this is difference of sets. You identify the common elements. 2, 3, 5, 7. In first set, what elements are remaining other than common elements? That is the answer. What elements are remaining? 1, 4, 6, 8, 9. Okay, now I know what is A dash and what is B dash. Actually, I need to verify A dash intersection B dash. So, I'll calculate this RHS, A dash intersection B dash. You know how to calculate intersection of two sets. A dash intersection B dash. What is A dash? Look here, A dash is this one. Okay, you take this one A dash. Okay, A dash intersection B dash. What is B dash? You can look here, this is B dash. Okay, A dash intersection B dash. You observe what are the elements common in both. Is there any element common in both? 1 is common in both. Next 3, 9 is common in both. Next 3, 5, 7, 3, 5, 7. There is no other element common in both. Intersection means what? Intersection means the elements which are common in both we will write. So what are common in both here? 1, 9 are the elements common in both. So what is this? A dash intersection B dash. I will take it as 2. You observe 1. What is 1? A union B whole dash is set 1, 9. A dash intersection B dash is also set 1, 9. So from 1 and 2, what I can conclude? From 1 and 2, what you can conclude? I can conclude that what is 1? you observe what is one? A union B whole dash. A union B whole dash equal to what is 2? A dash intersection B dash. Hence, we verified first bit. A union B whole dash equal to A dash intersection B dash. Now, second bit. What is second bit? A intersection B whole dash equal to A dash in union B dash. Okay, I need to verify the second bit. Right, this is the second bit. Same procedure. First, I'll calculate LHS. A intersection B whole dash. Next, I'll calculate RHS. Later, I'll check that both are equal or not. For calculating A intersection B whole dash, you know this formula. A intersection B whole dash formula is what? Universal set minus A intersection B. First, I'll calculate A intersection B. Okay, A intersection B. What is set A given in the question? In the question, set A is given as 2, 4, 6, 8. Intersection. What is set B given in the question? Set B is given as 2, 3, 5, 7. Okay. Now, this is intersection. Na? You identify the common elements. 2 is the common. Next, here 4, 6, 8 is there. Here 3, 5, 7 is there. So, the only common element is 2. You know how to calculate intersection of sets. Intersection means common elements we will write. Okay. Now, I need to calculate this A intersection B whole dash. Na? So, what is A intersection B whole dash formula? Universal set minus A intersection B. What is universal set? In the question, they given universal set as 1, 2, 3, 4, 5, 6, 7, 8, 9 minus A intersection B, we got it as 2. Now, you observe the common elements in both the sets. 2 is the element common in both the sets. So, what elements are remaining in first set? 1, 3, 4, 5, 6, 7, 8, 9. So, A intersection B whole dash I calculated. What is A intersection B whole dash? 1, 3, 4, 5, 6, 7, 8, 9. Now, what I'll do, I'll calculate this RHS. A dash, I already calculated A dash in this bit, right? A dash, B dash, both are needed. Okay, I'll copy those things. A dash as well as B dash. A dash, B dash. Okay, I'll calculate A dash as well as B dash. Okay, now what I need here? A dash union B dash I need. Okay, A dash union B dash. A dash union B dash. Okay, what is A dash? 1, 3, 5, 7, 9 union. What is B dash? B dash is 1, 4, 6, 8, 9. Union means you know how to write union of two sets. First write the first set full. 1, 3, 5, 7, 9. Okay. Next continuation. You write 1. Next this full set you write 1. 1 already written. Next 4. You write 4. 4. Next 6. 6 is there here. Okay. 6. Next 8. Okay. Next 9. 9 already written here. So no need to write it again. Oh, okay. No. 9 already written here. No need to write it again. So actually in this there is no proper order. Just to check first and second. I'll do one thing. I'll write in a order wise. First 1, next 2 is there, no. 3, next 4 is there, yes. 5 is there, next 6 is there, 7 is there, 8, 9. Just written in order wise so that we can easily verify. A dash union B dash. I'll take it as second one. You observe first one. A intersection B whole dash. What you got? 1, 3, 4, 5, 6, 7, 8, 9. 1, 3, 4, 5, 6, 7, 8, 9. You can observe 1 and 2. Both are same. So from 1 and 2, what I can conclude? From 1 and 2. What is the first one? A intersection B whole dash. A intersection B whole dash equal to A dash union B dash. I hope you understand. Hence, we verified both the bits in fourth question. You observe question number 5. Draw appropriate Venn diagram for each of the following. You observe this first one. What is this first one? A union B whole dash. Okay. we know that A dash means not A, B dash means not B. Like that we can say. Here A union B whole dash means not A union B. A union B whole dash means not A union B. You observe this. Here I consider two sets AB in the form of circles. This is set A, this is set B. In this Venn diagram, you show me where is A union B. You can see this part. This part is there now. What is this part? This part is A union B. We learned this in the theory part when we are learning definition of union of sets. Right? What is this? This is A union B. Here, what is there? A union B whole dash is there. A union B whole dash means not A union B. So, not A union B. In this diagram, this part is A union B. Na? Other than A union B, what part is there? You can observe this part. This part is not A union B. So, I'll shade that part, that not A union B part is there. Na? You look here, this slight green color one is there. Na? What is this? This is not A union B. It is very easy to say that which one is not A union B, right? So, what is this green color part? This green color part is not A union B. I hope you understand this. So, what I'll do here, I'll draw one small box in that whatever the color is there, that color is nothing but A union B whole dash. It's very simple. A dash means not A. B dash means not B. C dash means not C. A union B whole dash means not A union B. So here this part is there. Na? This part is not A union B. Now we will try to understand this second bit. Actually we know this formula. In properties of complement of a set we learned this. A union B whole dash is same as A dash intersection B dash. So the diagram what you will get for this and the diagram what you will get for this, both will be same. However, I'll try to explain this in a different way, right? Okay, see this A dash intersection B dash. A dash means what? A dash means not A. First what I'll do, I'll mark not A. You observe here Venn diagram is there, na? I'll mark which one is not A. A dash, whatever I'm marking now, that is A dash. A dash means what? A dash means not A. Other than A, full part, you can observe, other than A, full part I am marking here. Other than A, full part I marked here, right? What is this? This, whatever the colored part is there, that is A dash. Okay. Now, I'll mark this B dash. B dash. What is B dash means? B dash means not B. You observe B dash. B dash means not B. See, other than this, remaining all part I'll mark. Please observe. Whatever I am marking now, what is that? What is that? That is B dash, not B, right? Okay, I'll try to mark with a different color. I think you can see this, right? With a different color. I'm marking, what I'm marking? I'm marking not B. Please observe. Please observe, not B, right? So here, what I marked here, that is not B. Please observe carefully, please. Right? So A dash is marked, B dash is also marked. Here A dash intersection B dash is there. That means the common part. What is the common part which is present in A dash as well as B dash? Please observe. Common part. Here in A dash, what part is there? In A dash, you can observe that this is A dash, right? This is A dash. In B dash, what is B dash? This other than B part. Other than B part. If you observe the common part, that means A dash intersection B dash. You know what is A dash. You know what is B dash. Then you will realize that whatever this space is there, this space is A dash intersection B dash. I hope you understand this. In case if you didn't understand, nothing to worry. Here, just delete this one. We know that A union B whole dash, this is same as A union B whole dash is same as A dash intersection B dash. So, same diagram. Just what you drawn for A union B whole dash, same diagram you draw and you write here A union B whole dash is same as, we know that A dash intersection B dash. This is enough. Actually, what diagram you will get for this A union B whole dash, same diagram you will get for A dash intersection B dash. I hope you understand this. Now see the third bit. What is the third bit? A intersection B whole dash. A intersection B whole dash. A intersection B. You observe this diagram. You know what is this part. This part is A intersection B. This we learn in intersection of sets definition. When intersection of sets definition is going on, at that time we learned that this is A intersection B. Here what is there? A intersection B whole dash. A intersection B whole dash means not A intersection B. Not A intersection B means which part? Look here. Here I am shading that part. Please observe. What I am marking now, that is not A intersection B. Other than A intersection B, whatever the part is there, whatever the part I am marking now, what is that? That is not A intersection B. A intersection B whole dash means what? A intersection B whole dash means not A intersection B. It can be understood easily. Look here. A intersection B whole dash means not A intersection B. Whatever the color part I shaded here, that part is what? That is not A intersection B. So here I will draw like this. I will take one small circle here, small square here, and I will shade. What is this part? This part is nothing but A intersection B whole dash. We know in properties of a complement of a set, we know that A intersection B whole dash is same as A dash union B dash. Okay, you observe here A intersection B whole dash is same as A dash union B dash. So no need of separate diagram for this A dash union B dash. Simply we can draw the same diagram what you drawn here, right? So I'll copy this and I'll paste here. Okay, so what is this? We know that A intersection B whole dash is same as A dash union B dash. With this fifth question is completed. What they are asking in the fifth question, draw the appropriate Venn diagram for each of the following. I hope you understand this. Okay, now we'll move to next question, sixth question. This is little tricky question. Many students will confuse, but actually it is very easy. You observe what is U? U is set of all triangles in a plane. All triangles means equilateral triangle, scalene triangle, isosceles triangle, right angled isosceles triangle. All triangles in a plane is the universal set. Okay. What is A? A is set of all triangles with at least one angle different from 60 degrees. What I'll do first, I'll write what is set A. Okay. What is set A? What is set A? E is the set of all triangles. Is set of all triangles with at least one angle different from 60 degrees. At least one angle different from 60 degrees. Okay, this is set A. At least one angle different from 60 degrees. What they are asking, what is A dash? A dash means complement of this set. They are asking what is complement of this set. A dash means what? Not A. Suppose if I'll try to explain this set contains what type of triangles. Suppose if I take a triangle with 45 degrees, 45 degrees, 90 degrees. Is this triangle present in set A? A triangle with interior angles 45 degrees plus 45 degrees plus 90 degrees. It is there in set A? Yes or no? Yes, because what they are saying, at least one angle is different from 60 degrees. Here all are different from 60 degrees. At least one angle is different from 60 degrees. For example, if I take a triangle like this with interior angle 60 degrees, 30 degrees, 90 degrees. Is this triangle lies in set A or not? At least one angle different from 60 degrees. You can observe here these two angles are different from 60 degrees. So A complement means what? A complement means not A. A complement means not A. What is the triangle which is not in set A? What is the triangle which is not in set A? If all angles of it, all interior angles of it triangle is like this. What happened in this? In this, all the interior angles of a triangle are 60 degrees. This is not in set A because set A contains a triangle in which at least one angle different from 60 degrees. But here all are same. Nothing, at least one angle different from 60 degrees they are saying. All are 60 degrees. So here what I can say here, set of all equilateral triangles. Set of all equilateral triangles is the complement of this set. Other than equilateral triangle, you take any triangle other than equilateral triangle. You take any triangle which contains at least one angle different from 60 degrees. Only equilateral triangle which contains all angles 60 degrees. So complement of set, this given set is set of all equilateral triangles. In this, all angles are equal to 60 degrees. That means whatever the triangle present in this set that is not in set A dash means not A na? Right? I hope you understand. Just try to think it little bit. Okay. Now we'll move to 7th question. You observe what they are asking in the 7th question. Find the blanks to make each of the following a true statement. Okay. Right. See, to do this problem, while learning complement of a set, we learn some properties. In that properties, you need to know that empty set complement is universal set and universal set complement is empty set. We learn these formulas. You must know these formulas to do these problems. Okay. When it comes to first bit, what they are asking? A union A dash. What is A union A dash? Here, I'll try to explain this with the help of Venn diagram. Okay. A union A dash. I'll draw set A. You suppose that this is set A. Okay. Where is set A? You observe this is A. This is A. Correct? Where is A dash? A dash means this part. A dash means this part, not A. Correct? A union A dash means what? A union A means this first part. A dash means this second part. Second part means this full. When we do A union A dash, what you will get? 1 plus 2. 1 plus 2 means what? This full you will get. Correct? This is A union A dash. I hope you are understanding. A union A dash is what? A union A dash is the universal set. I hope you got the point. Right? Now we will move to second bit. What is second bit? Pi dash intersection set A. You know that empty set complement is universal set. This is the formula, right? Universal set intersection A. Where is the universal set? This is the universal set, right? Where is A? A is here. You can observe that the set A is a subset of universal set. When A is subset of universal set, you know that A union universal set is universal set. A intersection universal set is A. Smaller set you will get. So when you do intersection, then you will get A only, because all the elements present in A are present in universal set. I hope you understand this. So empty set complement intersection A is A. Very good. Now come to the third bit. What is the third bit? Third bit is A intersection A dash. Here this is set A, correct? This is set A. Where is A dash? This is A dash. Is there any common element in A and A dash? A is different, A dash is different. There is no element common in A and A dash. We can easily say that A intersection A dash is a null set. Now last bit in this exercise, you observe here universal set complement intersection A. We know this formula. Universal set complement is what? Universal set complement is empty set. Empty set intersection A. You observe while doing empty set is subset of A. Empty set is subset of A. Here when we do the union of these two sets, you will get A. When you do the intersection of these two sets, we will get phi. So here what is the answer for this? Answer is phi. Right? I hope you understand this exercise.